Today I will conduct a free fall body experiment. By conducting this experiment, I aim to calculate the gravitational force by utilizing from the height and the elapsed time. And free fall motion is a special motion of constant acceleration because throughout the motion, acceleration is constant and downward, and it's approximately 9.8, and we will use this value in our experiment. My experiment involves two parts. In part A, I will measure the gravitational acceleration, and in part B, I demonstrate that the mass of an object does not influence the elapsed time, the time taken by a free fall body. For the experiment, first I measure the masses of objects. Here is the object 1 and it's 100 grams. And here is the object 2 and it's 30 grams. It will help me to measure the taken time. For each height, I will measure for 5 times in order to minimize the expected error. So let's start with our object 1, which is 100 grams and 1 meter. Second time?
0.38.
And we are moving to 1.25 meter. What was the time?
0.46.
Our third height is 1.5.
$0.58.
When it comes to 175 meter,
0.56.
And our last height value is 2 meter.
0.64.
We are done with our first object and move with our second object, which is 30 grams. And we noted our measurements into the table.
0.41.
Our second height value is 125, and let's do it.
0.55.
And for 1.5 meter,
0.58.
And for 1.75 meter,
0.55.
and our last height value is 2 meter.
0.65.
And finally, by considering these results in table, for part A, it can be said that by taking average of each time, we can find experimental gravitational acceleration together with using the height values. And then we will compare it with accepted value, which is 9.8, and we can calculate the average error. And when it comes to part B, with this results in table, it can be reached that the mass of an object does not influence elapsed time. However, in this table, it can be seen that the most of the values for same heights are different because of the measurement errors and air resistance. We cannot neglect air resistance in a real world. So these are ideal values.